Exam Readiness Certified Developer Associate track. Great to have you along, and welcome. My name is John. I'm going to be the presenter here this evening, and I am going to be going through in the next couple of hours a little bit about the AWS Certified Developer exam, a little bit about the main pillars of the exam, and kind of walk you through some of the topics that the exam is built around. Maybe we'll throw in a couple of sample questions in there as well. So this is it's going to be a good session, hopefully, for everybody. Again, welcome. It's great to have this kind of attendance come out for the course itself on, like I say, on a Friday here. And we're going to go through these particular subject areas, what to expect, and then we'll go through the 5 domains of the AWS Certified Developer exam, talk a little bit about some of the deployment, security, developing, refactoring, monitoring, and troubleshooting domains. Like I say, talk a little bit about how the exam itself is built, and a little bit about some of the subject areas that they cover on those exams. This is not meant to replace our full comprehensive 3-day course on the developing on AWS. It's just kind of mainly to give you an overview, different things that you might want to think about studying for as you go along. And Alex was nice enough to put a link in the chat window there if you have access to the chat. And Alex posted a link of our webinar schedule, so you just get an idea of when the next one of these might run if you have an interest in attending it again. And in the course itself, like I say, this is just sort of an overview kind of the exam, give you an idea of what we're aiming for when the actual exam was written, give you an idea of the types of questions that you're likely to see on the exam, and give you some examples of that as we go along. And it would take about 2 hours for this particular session to actually run. So in the AWS Certified Developer exam, it was written around 5 different domains of knowledge. And you kind of see overall the weighting of these different domains in how the test was actually written. So deployment, about 22% of the exam was written around code deployment, and security, about 26% written around that. Developing with AWS, about 30%. Refactoring, 10%, small percentage there. You're likely to very well see a lot of monitoring and troubleshooting questions as you go along as well here and there. So, oh, great. I believe Nigel is online, and Nigel's going to be helping with some of the questions too in the questions block. Thanks very much, Nigel. Appreciate having you on board. Thanks for coming along and helping us out with this session. Awesome to have you. So, today's focus is going to be on question strategies and things to look for when you're choosing an answer, or how to look over, identify some of the key aspects of the questions itself that are being asked, what to study, things to know, practice questions in each domain, helping you identify maybe some personal gaps. And again, it's sort of an overview of the exam. It's hard to cram 3 days worth of knowledge into that we do in our developing course into 2 hours. We'll do our best. But there may be some more study that's needed on your part itself. And in that case, kind of use some of this session to kind of maybe figure out whether or not you have particular gaps in knowledge in that particular domain of the exam. Go back and do some some additional study before going out and trying to do the exam yourself. So we are going to just jump right into it. Our time is short, so let's get into the actual exam workshop here. Talk a little bit about the deployment domain. We'll start there first, and we're going to look at the certification objectives. This is really important because these are the same certification objectives that the test question writers themselves were given when they built the exam. So we're going to talk about how to deploy code using a CI/CD pipeline, processes as well as patterns. We're going to look at tools like AWS Beanstalk. So we need to know how to deploy applications using AWS Elastic Beanstalk, and how Elastic Beanstalk might go about actually doing different types of code deployments, how to prepare the application and package it to be deployed to AWS, as well as looking at ways to deploy serverless applications on AWS itself. The release processes and looking at how a CI/CD pipeline, for example, might be structured around a specific release process requires us to think about the different phases in the process itself. And each team might be doing this a little bit differently. But in general and overall, we might be able to break this down into these 5 key areas. And I've seen this same pipeline represented in just using 4 of these and kind of rolling tests into both the build and the deploy stage. But you get the idea that these are the general stages that you would see in a typical release pipeline itself. And so in the source phase, we would look at, okay, we're developing the code, we're checking it in to some sort of shared code repository. And that could be an AWS service like Code Commit, or it could be something like GitHub. And in this phase, once we check in, we might do some peer review, we might do some static code analysis here during this particular phase. And maybe what that does is trigger the next stage, which takes the source code and puts it into the build phase, which would handle things like compiling the code. And maybe at this phase, we start to launch some basic tests like unit tests, making sure that the code passes the build itself. We might also use some style checkers and other tools at this point to make sure that everything's in compliance with our standards for our particular code itself. We might connect, metrics on this phase. We might look at different metrics like, how many builds are we doing? How long does it take the builds to do themselves, and so forth. We can also containerize code here at this point. We could maybe build Docker containers at this point for maybe deployment on something like an ECS or an EKS on Amazon. And then tests. Tests are an important part of making sure that we kind of flush out how things are going to run. And so, we may have run some basic unit tests over in the build, but here, when we get to the test stage, now we want to look at how things integrate together. Did we just break some integration with other components that may be running as part of our application? How's the component that we developed, how's it going to develop under, perform under load? We might, if we have a user interface, we might want to test that as well. Security testing could be a really important part of this as well, as we may want to do some pen testing here. Something that I would maybe include as well is maybe doing some library checking against common vulnerability libraries and making sure that, maybe we didn't accidentally include a library that's particularly vulnerable in our code when a newer version might be out there. So everything passes the test stage and move on to the deploy stage, and we can either deploy into production environments, and there's various strategies for going about doing that, as we'll see. Then we can monitor it, and we can detect unusual or activity or errors in production. We can also feed information back into to the developers and tell them, what we're seeing in the production phase itself. And so, although this particular slide is always represented by a straight line, it probably should be better represented as kind of a loop. You always want to be feeding information back into your back to your development team as to what you're seeing in production and what improvements you could make. And things like creating good user stories around that, so that we can incorporate newer features into the next sprint cycle or the next release. So you'll hear the term CI/CD, and so we really need to define what both of these mean. And so continuous integration is the CI part of it, and continuous integration is the practice of continuously checking and verifying your code to create change with an automated build and test process. And so this has gained popularity in the past 10 years so that we merge changes together more frequently in our CI process. We develop new features more quickly. We write automated tests like we were talking about earlier. We improve the quality of software that's being released by taking a little bit less time. We kind of shorten that build cycle up a little bit as well, so that we're constantly doing smaller builds as we're checking in more frequently. So in the CI process, typically we're going to stop at the build stage, and then we'll look at continuous delivery from that point. And continuous delivery extends CI to include things like running more automated testing and verification, and testing out production-like stages, and making sure that everything is passing, running very similar type of infrastructure that we might run actually into production itself. So our test environment looks very much, or I would say almost identical to how we're going to run that in production. So continuous delivery may extend to actual production deployment. In some cases, you may choose to gate on production. Or if you're very mature, you might move to more of a continuous deployment process where you're deploying your code into production automatically because you have a high degree of confidence in all your tests, and maybe you're deploying maybe into a production environment, but doing maybe a smaller rollout, seeing how that code is behaving in production without breaking the current application that's actually running out there today. So the difference in terms of continuous delivery and continuous deployment really tends to be whether or not you're gating on deployment to production or not overall. And so there's going to be various tools that we're going to interact with in the AWS space that you might see that go along to support these different phases in the code deployment process. So we have code commit, which is kind of like our version of GitHub somewhat. It supports Git type commands, but it's a private code repository that runs inside of your AWS account, where you can use it to check in code, check out code, create code branches. You can also, from this point as well, create pull requests that allow you to merge the code back into the main branch itself, and even have a certain number of approvers set up to basically go and say, yeah, okay, I'm going to actually approve this branch coming back into the main branch itself. For automation of building of code, we have our Code Builder suite. And Code Builder is a tool that requires just setting up permissions for being able to run automated builds that you don't really have to worry about scaling the build server. That's really interesting because I don't have to worry about I'm doing too many builds, or the instance size that I chose for the build server is not quite right. You don't really have those concerns inside of Code Builder. You have various testing suites that you can deploy, some of your tools that you can deploy from maybe something like your Jenkins tools that you automatically run your test suites. For deployment, we have Code Deploy, which can deploy things like software to EC2 instances, but also quite interesting about Code Deploy is they can also deploy things such as Lambda functions. We can run our serverless Lambda functions and have an automatic deployment for those as well through Code Deploy. And for monitoring all of this, we can do tools like X-Ray and CloudWatch. So we can use X-Ray to kind of trace the different path that your code is taking as it's talking to various AWS services, see what service it's talking to, how long it took, what was the result of that, kind of monitoring that through X-Ray. And CloudWatch is just a way of getting metrics about some of these various services that you're running on in AWS. How many Lambda functions are executing? Were there any errors, and being able to pull those out of CloudWatch? Or the EC2 instance that you're deploying code to, how busy is that instance? How much disk utilization, how much memory, and how much CPU utilization is going on. And the tool that you see at the bottom of the slide here, the one listed as Code Pipeline, is the one that helps us orchestrate the movement of all of these all of these, from check-in to build to testing to production, deployments, and so forth. Code Pipeline helps us create kind of an automated pipeline that helps to do this all automatically. So we can set up really nice pipelines to take your code from one stage into another, all the way into deployment, in fact, if we wanted to. So these are some of the AWS tools that we might see in our deployment domain for actually deploying our actual code here. Let's go take a look at our first sample question, and maybe, I don't know if you guys could maybe post this into the questions bank. This is kind of weird. I'm telling you to post an answer to the question in the questions window, but I think it'll work. So we have a question here. This is a single answer question. So we only have to get one of them here. Which of the following AWS services allow you to automate your build, test, and release processes every time there's a code change? What do you think about that one? So we look at the question and it says we want to automate our build, we want to automate our test, and we want to automate our release processes. Okay, well, gosh, looking at the choices here, I'm going to rule code commit out right off the bat, because that's just a repository. That's just a place where I actually go and put the code. So let's take that one out. Let's see. CloudFormation is actually a great tool for launching underlying infrastructure. I like it. It's a great tool for it, but it doesn't really help us automate that stage. So let's take that out. Code build is interesting, but it only automates the build phase, or it only does the build phase, and it doesn't really do the others. And then X-Ray is a good monitoring tool, so most of you have said E by now, or want me to get to E. And you're right, it would be Code Pipeline. That would be the tool. It acts as an orchestration tool for deploying the code into one stage to the next. So as we check it in, we can automate it, send it to build, we can automate the deploy process, and even other tests along the way here. So Code Pipeline would be our answer here. When we go to deploy on AWS, there's a couple of general rules that we want to remember about deploying applications in the cloud in general. These are very good things to remember along the way. This slide has got some rich information in it. But a couple of just general rules that we always try to stress in AWS for deployment of applications in the cloud in general. And the number one thing that you see there is multiple availability zones and multiple regions. So multiple availability zones means that my applications get spread out across at least 2 different availability zones when I've deployed it into a region. So typically sitting behind a load balancer. The load balancer is checking the health of things like the applications that are deployed on those EC2 instances there. And if a particular application stops responding, then the load balancer automatically stops sending traffic to it. So health checks are important. Designing stateless applications so that I don't have any one application server there in that picture that I grab a state object on and then force the user to come back to the exact same application server each and every time they transition from one page to another. Instead, I might store my state on like a DynamoDB NoSQL database, or I might put it in cache to even get faster access to it. So a cache server, or perhaps a fast lookup on DynamoDB. And then I also want to design my applications for scale. So I'm only, I'm not getting a lot of traffic today, and 4 servers are handling it. But tomorrow I see a surge in traffic, and all of a sudden my applications get overworked. In that case, I want to be able to scale automatically to meet the demand. And auto-scaling is a service that, in conjunction with the service we just talked about a moment ago called CloudWatch, can help us meet our scaling demands and allow us to scale our applications to meet the demand by monitoring some specific metrics. So maybe we're watching the application fleet, we're seeing a high CPU utilization across the fleet. That triggers an alert which is tied to an auto-scaling action, which scales the size of the fleet for us. So we always want to design for failover. If an availability zone or an EC2 instance were to go down, we want to have at least multiple of those. We want to be checking the health of those. We want to store state somewhere externally and not on the web server itself. And we also want to build scaling into our applications. And so using services like auto-scaling can help us do that. And we've looked at some deployment tools for deploying code into the cloud. A couple others that I really want to call out for you that are going to be interesting for you. I would definitely, just getting sort of a general overview, know that, for example, with Elastic Beanstalk, which is a tool that we primarily designed for developers themselves, you don't have to worry about managing infrastructure for your application. You simply package up your code, give it to Elastic Beanstalk. So maybe you take your PHP app or your Ruby app, you package that up, give it to Elastic Beanstalk, and Beanstalk can then create the underlying infrastructure for you to actually run that code in the cloud itself without having a requirement that the developer themselves know a lot about cloud-based infrastructure. They can just write the code, give it to Beanstalk, and say, hey, I need something to run this, and Beanstalk can take it from there. OpsWorks is a little bit more of the configuration management tool. It allows you to be very specific about the life cycle of your application, and it relies on underlying services like Chef or Puppet for its orchestration. And with things like Chef, for example, you can craft custom recipes for specific lifecycle events that occur in your application. So as you deploy a new instance, for example, if you have a requirement to, as a result of updating or deploying that new instance, you have a requirement to update a configuration file on the rest of the instances, let's say. You could write a custom recipe in OpsWorks to modify that layer of your application and have it make sure that it goes out and touches every single instance and does the modification for you in sort of an automated way. So you can write these custom recipes that allow you to manage your application in layers. So it's much more a configuration and a lifecycle management tool over time for an applications as well. And I mentioned a minute ago that CloudFormation was our infrastructure deployment tool. It is a really powerful tool for deploying all kinds of infrastructure in the cloud itself in an automated manner. So a moment ago, we looked at Elastic Beanstalk, we looked at EC2 instances, we looked at a DynamoDB and an auto-scaling group. Well, we could define a template that defines all of those resources, and we could run that template through the CloudFormation engine, and we can have it create that infrastructure for us, all based on a YAML or JSON formatted template that we gave it that kind of said, look, here's what I want, here's the desired configuration that I want, go ahead and spin that out for me. So CloudFormation is a really good tool to maybe take your infrastructure and treat it just like you treat code. In fact, we actually call it that. We call it infrastructure as code. We want to create our infrastructure in a defined and repeatable manner, much similar to the way that we do with code itself. So Beanstalk is pretty well covered on the exam. At least it was when I took the exam itself. So a few things that you might want to know about Beanstalk. Make sure before going in, you understand a little bit about the Beanstalk terminology. So know what an environment is. Know what an application version is. Okay, so you can, in a single environment, it is possible to have multiple versions of your application. And Beanstalk has some interesting ways of deploying software there. So it could deploy both versions side by side and maybe allow you to switch from one version to another version, make sure that the new version's working before you take down the old version. Or it also has a kind of a rolling upgrade model too, where you can just upgrade your existing instances, and you can upgrade the code on the existing instances as well. Along with applications and versions come along a configuration, and configurations are just, what should I do when I start this particular environment? Maybe there are some file permissions that I need to set. Maybe there are some users I need to create. Maybe there's just some configuration files I need to build when starting this particular version of the application. that configuration goes along with Elastic Beanstalk. So really important here, one thing that I would want to know going in if I'm taking the exam, I'd like to know where those configuration files are stored, what directory. I'll give you a little hint here. It's called EB extensions, .eb extensions that you create, and you put your config files underneath there. But that's well worth your time to go out and review before taking the exam itself. And if you need to go out and talk to other services in AWS, so if your Beanstalk applications, for example, needs to interact with a S3 bucket, for example, it's going to need permissions to do that. Those permissions are typically defined in AWS using roles. So one of the nice things about Beanstalk is that you primarily focus on writing the code, right? Your role as a developer is to get the code running. You don't want to maybe know a lot about application deployment or operating system deployment or getting all that up and running for you. We can handle most of that for you. We can handle configuring the like the web server, the app server, the language interpreter, the operating system, the host. You package up your code, give it to us. We give you the underlying infrastructure to run all that. That's really the goal of Elastic Beanstalk. To actually do that. And Elastic Beanstalk, along with that, it can create highly available versions of your application. So I could actually say, hey, look, I want this is my web application. I'd like it deployed behind a load balancer. I'd like it deployed with an auto scaling group, and create some alarms for me that will automatically scale those instances for me. It'll spin up the EC2 instances. As I mentioned, it'll create the load balancer. In some cases, you can have it configure the database for you. So Beanstalk is a pretty powerful resource for creating a web server environment for you. So let's look at another sample question here. Let's look and see here. Elastic Beanstalk can create a web server environment with several resources here. So it's asking us to choose four resources that we know Elastic Beanstalk can create. Well, so I just mentioned a couple of them there. I mentioned an EC2 instance, so that'd be a good one. That's one thing that we know Elastic Beanstalk can create, because that's primarily what it was designed to do, is to create a server for you to run your code. So that's good. I mentioned a load balancer, and I mentioned an auto scaling group as well. So that those three components we know that Beanstalk can deploy. Gosh, there's only one more. We just need to really figure out what the fourth one is. Anyone want to take a shot at it and guessing what the answer might be here? The fourth one? Someone says A, B, C, D. Absolutely right. One thing Beanstalk can't deploy is it can't deploy Lambda functions there. Absolutely. So in this case, the four answers that are correct are S3 bucket, load balancer, auto scaling group, and EC2 instance. And as I was talking about before, this is a good example of CloudFormation. We have a template that kind of defines what we want. The template is our kind of our source file. You know, if we're thinking like developers, right? We're thinking like developers here. The template is our defining resource, what we want to build. So we list in all of our resources there. I need a VPC. I need an EC2 instance. I need a load balancer. I need an auto scaling group. I need a DynamoDB. We would create, or we would define those resources in the template. CloudFormation is kind of similar to our compiler for our code. So CloudFormation takes the template, it runs it through the engine, and rather than producing an executable like a compiler does, instead it creates a stack, and the stack is the collection of resources that CloudFormation generated from that particular template. And we can monitor the state of our deployment with CloudFormation. We can see what resources are currently in progress of creating. If it fails, so if something fails to create, by default, CloudFormation rolls the entire template back, and anything that's created up to that point, it automatically rolls everything back for us. The main parts of a CloudFormation template are its description, that's optional, but it will typically have a metadata section as well as a format version of the template. And then it will have, along with that, 5 key areas. So it will have parameters, mappings, conditions, resources, and outputs. Those 5 things can be made up or can be found in a CloudFormation template. Now, one that's absolutely required to be there is resources. The other ones are kind of optional there, but parameters kind of act as input parameters to help us make the template more portable by asking the user for input before it's run, so we don't have to bake those values into the template itself. Mappings to help resolve differences across regions. Outputs to return data back to a user once the template is run. And conditions, which are interesting. Conditions are I'm using the same template to deploy the same application infrastructure into dev as I am to prod. But in prod, I want a little bit bigger database, or in prod, I want a little bit bigger EC2 instance size. I want some things to be slightly different when I go into prod. So maybe I create a parameter called environment. And when the environment is prod, then I will have a condition that says, okay, well, this is in prod, so give us a little bit of a bigger instance size here when you're going out and deploying this. You'll also find inside of CloudFormation intrinsic functions, things like ref or built-in functions that are built into CloudFormation, pseudo parameters, custom resources, which can, if CloudFormation can't do it, it can call into something externally, and conditional expressions as well can be built into CloudFormation templates. The next sample question here is just saying which of the following are all valid sections in an AWS CloudFormation template. It's asking us to choose 3 different answers here. So which 3 are valid here if we're thinking about the valid sections of a template itself? We're determining what those are. Well, parameters, we just looked at that. That looks to be valid. So parameters is a good one. I didn't talk much about anything called services in a CloudFormation template, so let's rule that out. Now we only have to rule out one more. Outputs, that's valid, but declarations, didn't really talk about that as much, but resources is required. So parameters, outputs, and resources are the required sections of a CloudFormation template. All right. We also don't want to just talk specifically only about infrastructure, though, and this test does cover a lot of serverless computing, so it's important to understand in serverless that in a traditional deployment that everything's running on an EC2 instance, boy, we have a lot of things to do. We have to provision an EC2 instance, for example, install an operating system, then we got to get the application running, then we got to build our applications, okay? Then we need to configure our auto-scaling and load balancing. Then we need to continuously patch and secure and monitor those servers and make sure maintain them and maintain the health of them over time. Where if we look at building serverless applications, we have to build and deploy our applications and monitor and maintain them over time. A lot of the undifferentiated heavy lifting of managing the infrastructure, that falls to AWS, and AWS kind of manages your servers. What you do is you write code and you monitor that code and maintain it and lifecycle over that. And then you use some of the various serverless tools to kind of either trigger code execution and without having to maintain hardware or maintain EC2 instances and maintain infrastructure, you're allowing AWS to kind of do that undifferentiated heavy lifting for you. And you're just using the server service on demand, for example. So our primary serverless compute application is Lambda. That's where your code runs. That's serverless computing right there for execution of code. And maybe you call that code through an API gateway function that you call from maybe a static web page. And the static web page is running in an S3 bucket. And the user clicks on a button to post a post some data into a database. That API gateway function launches the Lambda function that takes the data and writes it into DynamoDB. DynamoDB is very easy for you to configure. It's a NoSQL database. You just require a couple of main parameters that you have to go in and configure for it. And then everything else is just managed through API calls that you use to interact with it to add data and look up data from the NoSQL database. You can also enable things like inter-processing messaging. So if you have to call another component, for example, you could do that through an SQS queue, simple queue service, as well as SNS, simple notification service messages. You can send out a notification to all your subscribers. If you have to orchestrate a number of functions where you have a number of different serverless compute functions, you have to set up some orchestration so that the output from one function maybe feeds into input to another function, or maybe you need to run a couple of functions in parallel, or maybe you need to have multiple paths that you can take on a branching condition. Well, AWS Step Functions allows you to kind of automate all of that through an orchestration tool that allows you to specify the flow of your application across different serverless functions that you're creating. We also have some analytics tools for managing things like streaming data or querying data from an S3 bucket. Those are Kinesis, which can manage streaming data. And Kinesis is a tool that basically allows you very simply through setting it up to create a stream application where your producers that are producing data can put data on a stream. Then you can write consumer applications like Lambda functions to pull that data off the stream. And it gives you kind of a buffer between the two of them so that if you wanted to say, maybe you have an IoT device out there that's producing some data, you want to take that data and write it to an S3 bucket, you can use Kinesis to kind of help you orchestrate that particular workflow. So the data gets put onto the stream by the IoT device, and then it gets read off the stream by a service like Kinesis Firehose written into S3. Then you could use a service like Amazon Athena to maybe even go run SQL queries against that data that you just put in S3, our simple storage services. So interesting ways to create serverless platforms here, or use some of the serverless platforms to build various applications that we have in the cloud itself. So again, maybe I'm interacting with a static website that's hosted through Amazon's CloudFront. The static website is the back end is actually stored in S3. The user hits the website. It's a survey that says, hey, what did you think of the training that you took today? And you fill all that out. There's a little post function at the bottom of that that says submit. You hit submit. That calls an API gateway function. It launches a Lambda function that stores that data into DynamoDB table, and maybe even sends a notification to somebody that says, hey, a new survey just got filled out. And if we wanted to authenticate that, well, we could even do that with a service called Cognito there to help us do that as well. So we didn't harm a single web server in the making of this particular slide. We didn't require to spin a single web server up. We did this entire application all with these various serverless services. But deployment can get a little tricky here. And so, I've got all these components and I've got the interaction defined and I've got the code written. How can I go about rolling all that out into production? We have what's called the serverless application model for that helps us with CloudFormation extensions to help us roll out serverless resource types like APIs and functions and tables and so on. And it supports anything essentially that CloudFormation itself supports. So Lambda is a pretty powerful way of creating event-driven processing in the AWS cloud. And it's quite an interesting way of creating applications that are triggered off of things like a change of a data state or a request to an API gateway or even a schedule that you define, and all different types of languages that Lambda supports today, and it can interact with other AWS services as well. So you can have any number of event sources out there like S3 or DynamoDB. A new record hits a DynamoDB table that generates a Lambda function that goes and does something with that, or a new file hits an S3 bucket that launches a Lambda function that maybe takes and populates that data into S3, or a new record hits a Kinesis stream that launches a Lambda function. We can have all different sources out there that trigger Lambda functions out there. I already mentioned things like API Gateway or even IoT that can do it as well, and step functions that can help orchestrate it. And all of these different sources out there allow us to launch Lambda functions. It could just be like a scheduled task. You can have what's called a CloudWatch event that kicks off at a specific time and launches the function as well. So you can, and as I mentioned, you can deploy Lambda now today through CloudFormation using the serverless application model extensions that we looked at. So that allows us for ease of developing in one environment, like our dev environment, and taking that deployment and pushing that out into our production environments as we go. So sample question for this one is how can you deploy a Lambda serverless application? And it's recommending that we choose 3 here. So we can choose 3 answers here for deploying Lambda. Well, we're deploying a Lambda serverless application. Now, you already heard me talk about SAM, so I'm going to go ahead and give that one to you. And I think earlier that I mentioned code deploy as well. So now we're down to 2 choices because we just need one more. And that's, can we deploy a Lambda service through code commit and CloudFormation, or CloudFormation deploy command? And someone has already posted the CloudFormation deploy command. Code commit is a great repository. That's a great place to check in your Lambda code, but it's not going to deploy anything there for you, so it's not considered a deployment service. It's a repository service. Okay. So those 3. So a couple things to take with you here. All right. Elastic load balancing and auto scaling are designed to work together. Okay. The auto scaling group typically starts an instance, registers it with an elastic load balancer. We like scaling out in the cloud. We like adding to our layers horizontally by adding more instances or adding more resources in a horizontal fashion rather than scaling up the resource vertically. So scaling out is better than scaling up. Elastic Beanstalk allows you to focus on building your application and not having to worry about a lot of the underlying infrastructure deployment, whereas CloudFormation gives you a lot more control, allows you to have a definition of resources that you want to create and run that through the engine. And a serverless application is typically a combination of Lambda code plus maybe other services that are triggering it or that Lambda is interacting with. And some additional resources there, some documents on the AWS website. You definitely check out Elastic Beanstalk. Refresh yourself on that before you go take the exam. Also refresh yourself on Lambda as well. And, check out some of the other CloudFormation and serverless application models as well. So moving on to domain 2, which is security. A couple of axioms on the test for security are make authenticated calls to AWS. So you need to know how things are called at AWS. Encrypt and how to implement encryption using AWS. And implement application authentication and authorization here on AWS. So we have this slide in almost all of our courses that we deliver today. They are the shared responsibility model, which talks about how AWS is responsible for security of the cloud, but the customer is responsible for security in the cloud. So AWS's responsibility is to make sure our regions, our availability zones, all those different data centers that we build in those availability zones are secure. The equipment that's inside of those locations are secure as well. The compute, the storage, the networking, the databases that are inside those. Those are secured. We limit access to them. We make sure that we monitor activity inside of there. We have things like fire suppression systems. We have things like internal auditing of personnel that are going in and out of the facility. And we implement that at AWS to protect the resources and protect those locations. You're responsible when you spin up an EC2 instance, for example, for security in the cloud. So things like the patching of the operating system, that would be something that you would be responsible for. The application maintenance and who has access to those applications are things that you're responsible for. The security groups, whether or not the data is encrypted or not, or whether or not you're using encryption in transit or not, as well as securing access to your data, are all things that you're responsible for in the cloud itself. So make sure you understand the shared responsibility model. You may see questions that look very much like this on the exam itself that will ask you which security aspects are your responsibility, okay? So you would need to know that in this case, this is asking about the customer responsibility. So I need to think about security in the cloud. Is lifecycle management of IAM credentials, is that something that is my responsibility? Why, absolutely it is. What about controlling physical access to the compute resources? No, that's something that's AWS's responsibility. That's what we do. One more. What about securing access control list settings? Yep, that would be your responsibility. Encryption of block stores, yes. Patch management of EC2 instance, yes. Decommissioning of storage devices, no. That's something that we do. We actually shred them at the end, their end of life there when we decommission them. So those four would be the customer's responsibility in the cloud itself. And your EC2 instances and your RDS databases, your elastic load balancers, those all run inside of a VPC. I would highly recommend that you review your VPCs. You need to understand things like what a subnet is, which is what it's confined by. It runs inside of a single availability zone. You need to understand the controls to get into a VPC, so things like a network ACL, how it's considered stateless versus a security group, which is kind of an instance-based firewall. That's stateful. It might be a good idea to understand the difference routing-wise between a public subnet and a private subnet. And I would also throw in different connectivity options. What's an internet gateway? How that allows access to and from the internet versus a VPN, which maybe is going back to a private data center. So it's a private network that's set up between them as well. How do we monitor traffic into and out of a VPC? We do that through VPC flow logs. So VPCs are always a rich source of questions, and you may get some security questions around them, around securing your instances that are running there. Well worth your time to kind of review that, make sure you know those things. Knowing how to protect data in transit and at rest. Now I'm going to give you a little tip. If you hear the term data in transit on an AWS, or you read that on an AWS exam, I want you to immediately start thinking SSL/TLS-based protocols, okay? Because that's probably going to be what you need to look for, all right? Unless we're talking about a VPN, which maybe then we're talking about IPsec. But the first thing I want you to look for is TLS as an answer. Now, that's encryption of data in transit. At rest, you're typically talking about bulk encryption, where you're using the same key for encrypting and decrypting the data. So you want to review things like the key management service, where on the AWS side, we're storing a key there when we're encrypting the data on your behalf in the cloud itself. So we receive the data, we encrypt it, and we store it for you. Versus client-side encryption, where you may do that encryption on your end before you send it to us, and then we're not involved in the encryption at all. So know your encryption options. I don't think you'd see a lot on Cloud HSM, can't say for sure, but just in case, it might be worth reviewing the differences between a shared tenant KMS versus a single tenant Cloud HSM device that we can deploy in your account as well. Know that there are multiple ways to encrypt data on S3. There's actually 4 ways, and those 4 ways are represented on this slide. This is a very good thing to remember. You could encrypt it client-side. We could encrypt it for you on S3 as you send data to S3, and we'll manage the key for you so you don't have to do any key management. You could create your own key in the KMS, and we'll encrypt it for you automatically with a key that you created. That's called SSE-KMS. Or you could tell S3 to encrypt it, and you could pass S3 an encryption key to actually use to encrypt the data. That's called server-side encryption, client-supplied keys. So it's well worth your time to make sure that you know those 4 ways to encrypt data on AWS. Server-side encryption just means that our processors are going to be doing the encryption. You're not going to encrypt the data on your end. We are. So services like S3 support server-side encryption. It's an optional step. You have to turn it on for your bucket, but it's simply a checkbox to enable it. Glacier, data that you write into Amazon Glacier, which is more of our long-term archive, is encrypted for you by default there, rather than it being something you have to turn on. All data in Glacier is encrypted by default. RDS can encrypt data for you as well automatically. With RDS, you can enable encryption. It's an option. It's something, again, that you have to turn on for your RDS instance. And it might work a little bit differently if we're talking things like RDS for Oracle versus something like RDS for MySQL, for example. So the mechanics, the underlying mechanism might be a little bit different there. So let's look at a question here and look at this particular sample question. You created a messaging application with Amazon SQS. That's our simple queue service. So it's a queuing service for managing communication between different applications, for example, or components. You've enabled server-side encryption to encrypt the message body while exchanging sensitive data. Which service would allow you to manage and rotate your encryption keys centrally? So here's the key part of this question. Let's see if we can highlight it there. It allows you to manage and rotate your encryption keys centrally. And since I clicked too fast, it struck out A for you. So you only have to pick one of the 3. So what do you think? Which one of these would allow you to manage and rotate your encryption keys centrally? I'm going to throw out IAM for you because that's not the answer. So you're left with a choice of B and D. Both of those are valid things. They will both encrypt, but one will encrypt for you automatically and manage your key, and one will allow you to manage the key. And so when you're looking at that, D is something we can do, but we're managing the key for you. You can't rotate it. IAM, as I said, is not a choice. So that leaves you with answer B, which is customer managed key here in that case. So understand the different ways that you could protect the data that you're storing when you are doing that on AWS. Okay, which of the following request headers, when specified at an API, will cause an object to be encrypted by server-side encryption? So this is a sample S3 question, and this is saying, okay, we have to pass a header into our API request, which is going to cause the option to cause it to be encrypted by server-side encryption. All right, so we can look at request header. Well, that's a key right there, and it's an API call as well that will be encrypted server-side. So if I look at this, I'm going to rule out that first one. That doesn't look like a request header to me. I'm also going to rule out B because that also doesn't look like a header value to me. Now, the other two actually do look like header values. And so it could be one of those two, but the answer for this one actually is XM's server-side encryption. That's the one that is the actual value that you can send in as part of the API call. So there is a document on that called Protecting Data Using Server-Side Encryption with Amazon S3 Managed Encryption Keys. Might be, I'll see if I can post that in chat here. That might be worth your time to review as well. Now, all calls, all API calls into AWS have to be authenticated, and the service that we use to authenticate users in AWS is IAM, Identity and Access Management. In an IAM, we can create users, we can create groups, we can also create something called roles that, in the case of a user, represents a person or a service. An IAM group, so it's typically a collection of users that we're just managing as a group to make it easier for managing permissions to a group of people that need to do similar things in AWS. You're authenticated through a set of credentials. It could be a username and password. It could also be an access key and secret key in the case of API credentials. Roles are sets of permissions. His role is something that you can assume. I can allow someone to assume that role, and I can attach permissions to that role that allow you or allow a service to actually execute something against IAM or execute something against an AWS service by assuming that role. So things like EC2 instances or Lambda functions, for example, can assume roles, and that allows that service to go out and do something like talk to an S3 bucket or write to a DynamoDB database. So all API calls in Amazon have to be authenticated. And if I'm writing code as a developer against AWS, I'm probably an IAM user with a set of credentials that allow me to do that. But if my code is running in an EC2 instance and needs to talk to a DynamoDB, I'm probably using a role for that. But users, groups, and roles, their permissions come from the same place. It's the policy. The policy is the definition of what my permissions are. And as you can see, you can assign policies directly to users, you can assign them to groups, and you can also assign them to roles. And your policy determines what you can do. Your policy determines exactly what permissions, what you're allowed, what services you're allowed, what you can do on those services, and any conditions that may be associated with that. And both IAM users and IAM resources can actually be given permissions to assume roles, and that allows them to assume that role, get the permissions associated with that policy, and then affect the necessary service in that case. So for my applications inside the cloud, for example, like my Lambda functions that need to talk to DynamoDB, I would create a role. I would allow that Lambda function to assume that role. I would assign a policy that lets it do gets and puts on DynamoDB, and then I would let that. Then I would test my function to make sure that it could execute. Now, for sometimes I need to write applications that aren't inside the cloud that need to interact with the cloud. And I don't want to take and kind of bake credentials into those applications. Instead, I'd like to issue a set of temporary credentials. And so for that, we have the secure token service, which can be used to give users temporary credentials that have a expiration time associated with them. So embedded in those credentials are access keys and secret keys that allow me to go in and issue those temporarily, and then when that token expired, or when that expiration time expires, then I have to re-authenticate with like a federation somewhere. For example, maybe a SAML federation that I'm using to generate it, and then I have to regenerate those credentials again. So a lot of larger organizations don't really like to create a bunch of IAM users because it requires them to manage their user accounts in multiple locations. Like they're already managing their users today in Active Directory. They don't want to go create duplicate users inside of AWS and have then two different sets of user accounts and passwords and all that stuff to maintain. Instead, they just kind of want to federate. So they create portals for their users to log into that check their authentication. And they tell, hey, AWS, I want you to trust this identity store over here on my side that I've authenticated the user in. Just go ahead and map that user into a specific role and let them access DynamoDB at that point. So federations just allow me to trust an external directory store for authenticating my user without having to create user accounts for everybody that's going to access AWS. What about my customers? Like I'm writing a game app, and the game app is going to require the user that downloads my game on their iPhone to store data in DynamoDB. So I got to give them permissions as well. But I don't want to maintain IAM users for every user that comes and executes my game or runs my game. I want to just let them authenticate with an external provider, and I'll then trust those external providers for their authentication. Well, that's called a web identity federation. And web identity federations allow you to work with a large number of users, and you can use web identity federations for authentication. And then I don't have to create individual IAM users for them. I can have them go log in with Facebook, and I can then generate them a set of credentials for writing into, say, the DynamoDB and storing their scores for them. So that allows me to authenticate users that are external to my organization. It doesn't require me to actually go in and manage that. So any company, what a creative name that is launching a new game app for mobile devices. Users log into the game using their existing Facebook account, and the game records player data and scoring information, writing it directly to a DynamoDB table. What is the most secure approach for signing requests to DynamoDB API? So this is testing our knowledge of authenticating users that might be external to our organization. And it looks like it's telling us they're going to use Facebook to authenticate. So do we want to create an IAM user with access credentials that are distributed with the mobile app to sign requests? Well, that's creating an IAM user for every user that downloads our app. No, I don't like that. That's awful. Distribute the AWS root access credentials with the mobile app to sign into the request. So basically they're saying bake in the root account credentials for your AWS account into that mobile app. No, that's a terrible idea. Let's not do that. That's awful. We should never bake credentials into the application, so let's don't do that. Request temporary security credentials using Web Identity Federation and to sign the requests. That is a good idea. And let's look at D, establish cross-account access between the mobile app and the DynamoDB table to assign the request. And no, that won't work either. That means that the user has to have their own AWS account for that to work, and we can't require every user that's using our application to have their own Amazon Web Services account. So C is the best answer here. All right, so couple of axioms. Security groups, which we talked about in front of EC2 instances, are allow only. So we can open up ports on security groups, like we can open up port 80, we can open up port 443. We can even open those up for specific IP addresses and things like that. But we can't deny a particular block of IPs. Like I can't say, I just want to deny access from a specific IP block range to my web app. You could do that with network ACLs. They'll allow you to explicitly deny a range of IP addresses, so that's good. Always prefer IAM roles if given the choice over any kind of embedding of access keys or secret keys into an application. If you have a question that shows up that says this service needs to talk to that service, how are you going to enable that look for a solution where there's a role in the answer, because that's probably going to be pretty close to the right answer. Amazon doesn't like the idea of embedding credentials into anywhere, and I don't like it either. So that's a good resource. Know your VPCs. I want to point that out. Know your VPCs. IAM, there's an IAM user guide you can go and review. There's some good information there on server-side encryption as well. Nigel was kind enough to point out a good security fundamentals video there. He put that in chat as well, so check that one out. That's a good resource as well that you may want to consider. Thank you, Nigel, for that. All right, so development with AWS Domain 3. So, well, in this section, this particular domain was basically the objectives for certification on it were to write code for serverless applications, translate functional requirements into an application design, implement application design into application code, and then write code that interacts with AWS by using APIs, software development kits, and CLIs, okay? So some of the key services that maybe make up this particular section, we've seen these before. S3, DynamoDB, SQS, SNS, Step Functions, API Gateway, CloudFront, Elasticache, and ECS. Look through each of these. S3 is a object-based storage. The key resource in an S3 is a bucket, and you choose a resource for that or region based on things like latency, cost, and regulatory requirements when you're creating your bucket itself. Every object that you store in that bucket has a unique object key that's addressable with a virtual hosted style URL that allows you to directly reference that particular object. Some people in AWS like to share things that are in their buckets, and they think the best way to do that is to go in and give the entire world read-write permissions. Well, that's a really bad way of doing it. That's done with things called Amazon S3 ACLs. When you want to share an object, rather than making the bucket publicly accessible so that the entire world can see the object, not only you, the way to do it is through things like pre-signed URLs. And pre-signed URLs allow you to share a URL with some embedded credentials with your friend to get objects out of the bucket. Doesn't publicly expose the bucket, and the URL has an expiration time associated with it as well. S3 also supports cores, which allows for one bucket to call for resources through a web application into another across a different domain. You can set up bucket policies in S3 that limit the ability for users with higher levels of permission to access specific things in certain buckets. Bucket policies in S3 are tied directly to a bucket itself, so that in the event that you have, say, Fred, and Fred is somebody that has S3 full access permissions, that he can do anything in S3, including deleting objects and deleting buckets. But I have this real sensitive bucket, and I kind of want to restrict Fred's access for it. I can create a bucket policy that allows me to attach it directly to this bucket and limit Fred's permissions that he got at a higher level. So here, I'm giving Alice certain permissions, but I'm probably going to deny everybody else in that case. So let's look at an example question here. You're about to provide an S3 bucket resource-based permission so you can grant access to your friend Boo. His AWS account number is the one that you see there, and his username is Boo. What should be the format for the ARM? Well, let's go back and look at the bucket policy here and see if we can get some idea of how that might look. So I'm gonna grant access to somebody from a different account. Okay, so I'm going to create this resource-based permission that's going to grant access from somebody from an external account. And in some cases, his AWS account number is going to be needed there to be able to grant that particular permission. So You have A, B, and C there. I don't know if you can see B. It looks like it's actually hidden there. But in this case, we're granting access to this account number to a specific IAM user. Okay, that's the thing that we want to kind of focus on in the question itself. Okay, those are the key parts of that. You actually can do this, so that's going to rule out C. C is the incorrect answer. And if you notice, the ARNs are kind of the things that are now different between the two. Okay, ARNs are the different things between the two here. And so our answer here is going to be B, which was kind of hidden from us. A little part of it was hidden from us there, but B is going to be the answer because, again, we're granting an IAM user from this account named this access to it, not a bucket from that account. Okay, that was the dead giveaway there. Okay. You run an ad-supported photo sharing website using S3 to serve photos to visitors of your site. At some point, you find out that other sites are linking to the photos on your site, causing loss of business, loss to your business. What's an effective method to mitigate this particular problem? So you're losing money. Other sites are linking to you. It looks like they're letting users view your pictures this way. So what's an effective way of maybe mitigating that? Well, store photos on an EBS volume of a web server. Seems a little drastic. No, I wouldn't go with that. Remove the public read access and use pre-signed URLs with expiration dates. That's interesting. Let's hold on to that option. Let's come back to that. Use CloudFront distributions for static content. I don't know. That doesn't seem like it's going to solve the problem to me. Block the IPs of the offending websites in your security groups. Now, that would work if we had security groups in front of S3, so I don't like that one either. It doesn't work in this case, so I would remove the public read access and use pre-signed URLs. That seems to be a good option. All right, so moving on to DynamoDB is our fully managed NoSQL database. Make sure you understand table items and attributes, because that's what you create in DynamoDB. You create table objects. You have to, at a very minimum, create a primary or partition key, which used to be called the hash key. You can optionally define a sort key, and then the combination of partition and sort key then is the unique value for every item in that particular table. And we store data physically based upon that partition key. So we hash that value and we pick a DynamoDB partition of where we store that particular partition key. And partitions are based on that particular key. So in DynamoDB, we require you to define a partition key, and then optionally, as I said, you can have a sort key. You can optionally create indexes in DynamoDB. They're called local secondary indexes. You can have up to 5 of those maximum, and you have to define local secondary indexes on your table during table creation time. So Dynamo's kind of really good when you sort of know the questions that you want to ask on the table itself. There is such a thing called a global secondary index in DynamoDB, and those can be defined after the fact. Global secondary indexes can have different partition keys defined on them, and what happens is that the primary table is updated first, then the global secondary indexes are updated automatically with the new data. And in global secondary indexes, you can not only have a different primary key and a different partition key, different sort key, you can also project in other attributes into the global secondary index that maybe you typically look up. When you typically look up address, for example, on the bottom example, you typically also look up name. So rather than having to go look up the name in the primary table, you can project that attribute into your global secondary indexes as well. One important point about global secondary indexes is that their read and write capacity units are provisioned separately than the main table. So this takes up storage and this takes up storage, and they take it up separately, and you have to create your read-write capacity units separately for global secondary indexes. DynamoDB can be accessed through reads, either eventually consistent or strongly consistent reads. So it supports both mechanisms for reading data from the table. When you do an eventually consistent read, you're basically reading from one of the replicas in DynamoDB. We always write to three different partitions, three different replicas, I should say. We spread those out throughout the region so that they don't wind up in the same physical location. So when you do an eventually consistent read, just read from one of those replicas. When you do a strongly consistent read, you read from two of them, and you make sure that those two agree before the data is actually returned. So strongly consistent reads, making sure that we are reading from two replicas rather than one. We don't get as high of a read throughput in that case. As we do for eventually consistent reads. So it's a little bit lower throughput in the case of our read consistency there. Read consistency units, read capacity units are specified in 4K blocks, and write capacity units are specified in 1K. So however many of reads, 4K reads you're going to do per second, and however many 1K writes you're going to do per second, helps to appropriately size your specific DynamoDB table. So if, for example, you needed to support 25 strongly consistent reads per second that were 15K in size, okay, so the read size that you're doing is 15K, and you're doing 25 of those per second, all right? And you needed to support one strongly consistent read per second of 4K. And so how many read capacity units, how many write capacity units would you need for that particular table in order to do that? Well, so we know that we express read capacity units in 4K. So we would need 4 of those to do a 15K read. All right, so we would need at least 4 for every single read that we're doing. For writes, so basically 25 times 4 is 100 read capacity units. Okay, so writes, those are expressed in 1K sizes. Oh, I'm sorry, and I'm sorry. Let me back up one more, because one thing I didn't point out there in that particular calculation. This is strongly consistent reads. Okay, so strongly consistent reads. So we need 100. If I was going to do eventually consistent reads, that calculation is slightly different. If we're doing that same exact formula, but our reads are eventually consistent. So again, we would need 4 of those for every read. And in this case, because we're doing eventually consistent reads, to do those same amount of reads on that same table, we only need 50 read capacity units in that case. So we could do the same amount of read throughput, but because we're only reading from one replica, we only need 50 read capacity units to actually do it. So we just take that number and divide it by 2 when we're trying to figure out eventually consistent reads. Okay. For write capacity calculations, how many write capacity units we need to support 100 writes per second of 512 bytes? Well, for that, we would need at least 1 write capacity unit. That is, because that's the unit specification size is 1K to do that write. So we would need 1 of those, and then we would just simply take that 1, multiply it by the number of writes per second. That's going to give us 100 write capacity units. DynamoDB streams are post-modification events that can kick off on the table as a result of, say, a item changed or a new item on the table itself. What happens is that when that new item or that changed item is done, it puts it on what's called a DynamoDB stream. That's available on that stream for 24 hours, and you can assign things like Lambda functions to be able to read off of those streams and maybe go update some other AWS service or do something with the data record itself. So DynamoDB also offers some other features like conditional write operations that allow us to check, see if a record's changed before we write to it. Optimistic locking with by the inclusion of things like version numbers and checking the version number of the record before we make the change to it, as well as batch operators to do batch operations like writes or gets on a group of records in DynamoDB as well. Dynamo also has its own cache engine, which is really neat. It's designed for really high scale and performance. It's called DAX, DynamoDB Accelerator. So if you need fast response times from your applications in microseconds, you can use DAX. It's a compatible caching service that can sit in front of DynamoDB, and then your application can go and check and see if the data is in cache first, before actually having to go pull the data from DynamoDB itself. So Dynamo has its own cache accelerator called DAX. It also supports global replication, so I can have replicas of my table that are created in multiple regions that Dynamo can populate automatically. So I add a new record here in US East 1, that record gets put out on the DynamoDB stream and automatically populates to other replicas located in different regions, like in this case, West 2 and EU Central 1. So you can set up global replication inside of DynamoDB. So a sample question for this one is, which of the following is an example of a good DynamoDB partition scheme for provisioned throughput efficiency? So this is testing our knowledge of good partition key schema, where if you remember, the partition key is kind of our unique value. And because the partition key determines placement, it's trying to test and see whether or not we have a good partition key there. So to get the most efficiency out of our storage. So remembering that the partition key is going to be what actually determines physical placement on disk, we might want to choose one that gives us the best distribution of data. So student ID, where every student has a unique identifier. That's interesting. A lot of students would be a high number of unique values. College ID, where there are 2 colleges in the university. Well, if that was the same, if that was the partition key and there are only 2 of those, that's not going to give us really good distributions. Maybe not that one. Now let's rule that one out. Class ID, where every student is in one of 4 classes. Well, if there's only 4 classes, that means there's only 4 unique values. Again, that might not be a very good idea. Tuition plan, where the vast majority of students are in-state and out-of-state. Well, that seems to limit it down to 2, so not a good unique key there. So student ID then would become the best answer in that particular question. So, another one. Let's look at this one. A security system monitors 3,000 cameras and saves image metadata every 30 seconds to an Amazon DynamoDB table. Each sample involves writing 512 bytes of data. Okay, so the writes are evenly distributed over time. How much write throughput is required for this particular table? So we have to remember here that one write capacity unit is 1K in size. That's what we have to run in our calculation. Okay, so we are writing 512 bytes of data. That's going to require one write capacity unit to do that. Okay, so we're writing 512 bytes. The throughput is, there's 3,000 cameras, so we multiply that by one write capacity unit, so that's 3,000. And we're writing every 30 seconds. So if we take that and we divide it by 30, well, that should give us 100 write capacity units. Okay. So that's how we would figure out the number of write capacity units we would need for that specific DynamoDB table. When using a large scan operation in DynamoDB, what can you do to minimize the impact of a scan on a table's provision throughput? So we're doing a scan, which means we're reading every single record in the DynamoDB table. It's asking us to minimize the impact of that scan. So we're going to read everything. We want to minimize the overall impact and size. In this case, the scan operation reads an entire page, so that's 1 meg by default. We can reduce the impact of that scan operation by setting a smaller page size for that particular scan. The scan operation actually provides what's called a limit parameter that you can use to reduce that particular impact on that particular operation. So we could use the limit parameter and set a smaller page size for it. Next, we're going to look at some of the SQS, SNS, and step functions features here for event-driven solutions. So SQS is our simple SNS, I should say, is our simple notification services. SQS is our simple queue service. So SNS pushes out notifications to subscribers, whereas SQS, you have a consumer that puts data into a queue, and you have then someone a producer that puts data into the queue, and then a consumer that actually is going to pull the queue for messages and pull data out of that particular queue. So in SNS, you have topics, subscribers, and message sizes. I post a message to a particular topic that gets pushed out to all my particular subscribers out there. In SQS, you have a queue where you put data into the queue, and then someone's job is to pull that queue, and they can pull it through a long cycle or a short cycle, but someone has to pull that queue, and they have to then delete the message by the time that the visibility timeout expires. Once the visibility timeout expires, then the message actually is unlocked, and someone else is able to actually go in and pull that queue, or another worker is able to go out and pull that queue. So in SQS, messages are persisted in the queue itself. So we can persist messages in the queue until someone goes and reads the message and deletes them. SNS just is basically a passive method of pushing out a message to a group of topic subscribers. Whoever subscribe to the topic, they're going to get the message. And we can send that out to many different consumers that are out there in many different consumer types. In SQS, you basically have kind of a send and receive message. One person puts the message in the queue, one person pulls it out of the queue, or one worker puts it in, one pulls it out. It's primarily a decoupling mechanism between the different layers of your application. So in an SQS application, again, it's my job as the consumer to pull the queue, and I can pull it real quick and just do a quick sampling and pull out a sample of the messages. That's kind of a short pull cycle. Or I can go out and wait for a longer time and pull messages in a longer polling cycle and just kind of wait a little bit for that queue to actually get messages if it's empty. And once I pull a message, I lock it, and I have until the visibility timeout to process that particular message. Then it's my job as the consumer to go out and delete that message. I don't know if the test still is as heavy SNS and SQS as it was back when I took it, but I will tell you I got a lot of questions on this back when I took my exam. So any company provides an online image recognition service and uses SQS to decouple system components for scalability. Amazon SQS consumers can pull the image queue as often as possible to keep the end-to-end throughput as high as possible. However, Company B is realizing that the polling in tight loops is burning CPU cycles and increasing costs because they're getting a lot of empty responses back. So how can Company B reduce the number of empty responses? So this is testing your knowledge of long cycle and short cycle polling. And basically here what they're saying is it looks like right now we're polling in short cycles, but we're getting a lot of empty responses back. And we're trying to improve the efficiency of those particular operations, okay? So Question or answer A says set the imaging queue visibility timeout attribute to 20 seconds. That's really not going to do anything for us. All that's going to do is just make the lock time, the time I have to process the message, 20 seconds. That's not going to control the polling cycle at all. Okay. Set the image queue receive message wait time seconds to 20 seconds. That's interesting. Let's keep that one in our back pocket. The message retention period, 20 seconds. No, that's just going to say how long the message can remain in the queue. So no, I'm not going to go with that one. And the delay seconds, message to 20 seconds. Delay seconds is just the amount of time to delay the first delivery of all messages added to the queue. So that won't really help us either. But B will definitely help us. Receive message wait time is a good one. So that's let's hold on to that. It's a good one because it's the maximum amount of time that the polling cycle, a long polling cycle, is going to wait to receive a call before the message for messages to become available. So it's going to sit there and wait to see if new messages become available while it's actually polling for them. Okay. Step functions, as I mentioned, was an orchestration tool. Step functions allow you to create complex series of interactions between multiple Lambda functions and allow you to, say, orchestrate from a starting point a function call to be called, and then as a result of that function executing, calling another function. So you have starts and you have ends, and between there you have different functions that are tied to different states in the step functions. And what you do is you create what's called a state machine that kind of defines the flow of actions inside of your step functions. And these can be coordinated to do things like passing values between functions. They can do things like calling functions in parallel, so you launch multiple functions at the same time, or to kind of create decision trees. So if the output of function A happens to be one value, call function 1. If it's a different value, call function 2, and so on and so forth. API Gateway can act as a front end to manage back-end systems that are running on AWS, and there's really good integration between API Gateway and things like Lambda functions. So using REST-like API calls, you can make calls through API Gateway that can launch Lambda functions, for example, and interact with services on the back end. And again, going back to our example application that we had earlier with the static website, we could have a website that we're publishing through CloudFront that has a static web page in Route 53 that asks the user for some input. They hit a submit function that calls an API Gateway function that launches a Lambda function that stores some data in S3 or stores some data in DynamoDB. CloudFront, it then is a caching service. So what it does is it allows us to cache content closer to where the user's actually at, rather than having that content have to be pulled all the way from the region every single time. So, you have your load balancer, but maybe you also have a lot of your static content sitting in S3. You can cache a lot of that content in CloudFront, pull it closer to the user, so time to load things like images or videos or static pages is significantly shorter because CloudFront, which is a content delivery network, helps to cache that closer to where the user's actually consuming it. So we can help improve the performance of our applications by using a content delivery network like CloudFront. Maybe we want to improve the performance of lookups on our databases. Maybe we're using some relational databases. We're trying to decrease the pressure on them. We could use a caching service like Elasticache to help speed up the performance of database queries by caching the most frequently used queries on them. Elasticache is two main engines that support it, Memcached and Redis, so you can use either one. But these are just a group of managed nodes that you can deploy at your VPC that allow you to cache frequently used data in in-memory EC2, or I should say in-memory instances, to help reduce the lookup time. And caching allows you, for example, to do a lookup and see if the data is in cache or not. So you go and look it up in Elasticache. Is the data there? If it is, that's a cache hit, returns that back to the application. If it's not, well, we need to go get that from the database. So we go pull the data from the database, return that back to the caller, but at the same time, we go ahead and set that value in cache. Or, maybe as you're doing updates in your application, you're updating an application, updating a database. When you go and you do the update to the database from your application, you go ahead and set the cache record at that time, do the update at that point. So you're doing a write through the cache when you're doing your update. So a sample question from these services would be, you've written an application that uses an Elastic Load Balancer to spread traffic across several web servers. Your user complains that sometimes they're forced to log in again, and this is in the middle of using your application. This is not how you expect your application to work. What's a possible solution to prevent this is happening? So sometimes your users are being forced to log in again. Users are prompted to log in probably because we're not storing session state correctly. So maybe we're storing it on instance and the user's getting moved off to a new instance maybe, or something like that. And we need a better solution to store that state information rather than putting it on the instance itself. And so, well, that rules out answer B right away. We do not want to store state on the EC2 web server instance itself, okay? So let's rule out A and B because those are both bad answers. That's probably what we're doing now. That's probably what's causing the problem. So now we have three choices. Use EBS, use Elasticache, and use Glacier. Well, EBS is a bad choice because that's on instance itself. We're actually, if we put it on EBS, we're just actually just doing it on even a slower. We're putting the state on something even slower, so that's bad. And Glacier is great for long-term archiving, but it'd be terrible for actually storing state. So essentially, we're just left with answer D. Elasticache would be great for it. It's in memory. We could look it up very quickly. We could point all of the instances to it and say, look up the state information there. Okay. Which of the following services are key value stores? And so you have to choose three of these. Okay. Well, alrighty. I'm going to rule out right away simple workflow services. That's a orchestration tool. It's not really a key value store. DynamoDB is. Elasticache is. So there's two of them right off the bat. It leaves us with SQS and S3, and it turns out that S3 is also a key value store, so that rules out SQS. So those are the three correct answers. All right, so let's move on to there finally, ECS, container services, Amazon's container services, ECS. So Elastic Container Services are for deployment, scheduling, and management of containerized applications that you're running on AWS. And so we deploy a group of nodes that you can deploy your containers on. You can manage those nodes as a group through ECS. We can even deploy an image repository for you to store your images in, kind of like Docker Hub, but kind of private to your own account so that you're not sharing them with anybody else. That's called ECR, Elastic Container Registry. So we can handle the deployment of your containers onto EC2 instances. In fact, with Fargate, we can even replace the EC2 instances, and we can just worry about orchestration of containers themselves and not have to worry about the underlying host that they're running on if you want. Amazon also produces a number of software development kits that are tailored to specific programming languages. So, if you're programming in Python, there's an SDK that they publish called Boto, for example. There's SDKs for Java. There's SDKs for C# and other platforms to help you simplify your application development. There's a number of IDE toolkits that will snap into a number of popular development environments like the .NET development environment or Eclipse or PyCharm as well. We also have our own IDE that runs in the cloud called Cloud9. We have a number of command line tools like the AWS command line to allow you to automate certain services with management scripts. So your test axioms for this section are choose managed services over unmanaged services. That is important. Choose an AWS managed service. Also, don't directly expose resources. Use edge services like API gateway. So in other words, don't directly expose your DynamoDB database to the world. Force it through a service like API gateway. Store sessions staying on the server is never a good idea. That's not a good thing to do. Yes, I did say Elasticache is deployed in a VPC. It is a managed service deployed inside your VPC. So you tell us where to deploy it, we'll put it there. Decouple your infrastructure, so don't directly hand off between layers. Instead, use things like queues or load balancers between layers rather than directly handing off between them. Domain 4 is refactoring. It's one of the smaller domains in this section. It's optimizing applications to use the best features of AWS and also migrating some of your existing applications to run on AWS. So when possible, what you want to do is automate things where if you have a situation, let's say, for example, you have a group of users, they're accessing a web server, and that web server crashes. Now, then they have to notify an admin manually. The admin has to launch and configure the new instance. That all takes time. A best practice would be to monitor that. Monitor it with something like CloudWatch. And CloudWatch can detect that the instance is unhealthy and kicks off a notification, but also begins the auto-scaling action to launch a new identical instance there. So you can have CloudWatch kind of watching this for you, and we can automate the response of fixing something like a failed instance automatically without requiring that the instance, that the administrator log in to do the configuration of that instance. Amazon recommends you design services and not servers. You don't need an application server or an EC2 instance for everything. Instead, think of what the service needs to do. Serverless solutions can be provisioned when you need them. You can use things like messaging queues like SQS to hand off communication between layers of your application. You can do things like storing static assets externally on something like an S3. You can handle user authentication and state storage through services like Cognito and Elasticache, so that you're not storing state on instances themselves. So don't just limit yourself to things like EC2 instances for managing infrastructure for everything, when there's services out there that can help you optimize your applications and let you focus on the code, and also not have to worry about the patching and the management of a lot of this stuff over time. You also want to avoid single points of failure in your applications that you write on AWS. So best practices would be things like creating secondary databases, like using RDS, for example, where you do a multi-AZ configuration. And if the main database goes online, that's okay. We have the secondary pick up the load, and we haven't lost any data as a result. As we mentioned, if you should use caching whenever possible to help minimize redundant data retrieval operations. And so in the case of an asset that you need that's stored in a bucket in US East Virginia, and the users are all sitting over there in Australia, well, right now, they'd have to all pull that object to be able to retrieve it. They would each experience the same latency. But if we simply hosted this in front of something like a CloudFront, yeah, the first user's got to take the hit. They got to pull it. But that gets pulled into CloudFront and gets cached there. And subsequent users at that point are pulling the cached version out of CloudFront itself. And that's going to help optimize that particular retrieval operation and reduce the time it takes to be able to retrieve that and reduce the overall latency for subsequent access. So use caching wherever possible in your applications themselves. So an application needs to save state for users. And you have a choice of these 4 AWS services to store that state. Which service would be the best one to use? Well, we're storing state, so we're going to be looking it up a lot, and we want the best one. That means there could be 2 answers that'll work here, but we want the best one. X-Ray is not going to do it for us, and Simple Notification Service really isn't going to do it for us as well. So that's going to leave us with RDS or DynamoDB. And DynamoDB is just more optimized for that than a relational database would be. So if I have to pick one of these, then I'm going to choose Dynamo because fast lookups on the partition key are something that DynamoDB does really well. So I'm going to go with that. Okay. Which Amazon service could be used for caching? And you have to pick 2 answers here in this case. So we're talking about caching services. Well, we just mentioned one, which was CloudFront. So that's one of them that we can do. And another caching service that we talked about a little bit earlier was Elasticache. So I can rule out S3, I can rule out Elasticsearch. Those 2 are good answers for which service can be used for caching. Okay. Migration of applications into AWS. What are some different migration strategies for migrating applications in? Well, there's a couple of them, the 6 of them that you see here on the slide for migration. Refactoring, replatforming, repurchasing, redesigning, retaining, and retiring. You can simply, in the case of a rehosting, you could just simply lift it and shift it into the cloud. You can just take what you're doing on-prem and just lift that into the cloud itself. You could re-platform it a little bit, maybe pick a better platform to put it on or a newer platform with a little bit better performance than what you're doing today. Maybe just repurchase the software in the cloud itself. Maybe go to the marketplace and find what you're using in today and just repurchase that for the cloud itself. Maybe you do a little bit of refactoring, redesign the code a little bit. You maybe take advantage of some of those AWS services that we talked about and kind of, gradually re-architect your solution a little bit to make it so where that you're taking advantage of what the cloud does a little bit well. That may take a little bit more time than something like a simple rehosting would do, but over time maybe you kind of redesign your application code, take advantage of what the cloud does well. Maybe you retire it. Maybe it's legacy and it's time to just shut it down. Somebody just forgot about it, kept it running. It's time to retire that old resource, that legacy product, or you just maybe retain the resource, keeping it running as is on premise today. So migration, like we said, take multiple paths here, and refactoring is then rewriting and then going out and looking at some of the different services we talked about, decoupling those, adding scalability into it, and re-architecting the solution so that, rather than this monolithic application that has all 3 of these components maybe built into it today, because this is what you've been running thus far. You got the file ingestion, file processing, file publishing, and you take out a little piece of that, and maybe you move the file ingestion, file processing into the cloud, leave the file publishing in your corporate data center. Then you start to investigate microservices a little bit. You start to break out some of these individual components, and you run the file ingestion piece on an EC2 instance and pull that into the cloud, and then you use some queues to communicate with the file processing layers, and those are running on EC2 instances that push the files into buckets and then send notification alerts to users and let them know, hey, the file processing has been done there. And so we start to, maybe decouple that a little bit. And then maybe we even go a step further beyond that and maybe go on to serverless. And so have the user upload the file to an S3 bucket. That kicks off a queue that the S3 puts a message into the queue, and we launch a Lambda function that processes the file, pushes the processed file into a bucket that launches a notification topic that sends the sends the notification back to the user that the processing is complete. So even now, we've decoupled the application. We've used AWS services. We've gone completely to a serverless solution. We're not having to manage any of the services here in our application. Instead, all of this was done by a serverless solution here in the cloud. So some of the services that can assist with refactoring a solution to be a more effective cost-saving option to compared to an existing on-premise hosted application. So which services can assist us with doing this? We want to have a more cost-saving option compared to an existing on-premise hosted application. So AWS static web hosting, yeah, that would work for us. EC2 instances to run the application along with an RDS database, yeah, sure. Or perhaps even DynamoDB functions or Lambda functions and DynamoDB for the data. Absolutely, those would all be good options for services that would work, and we could rule out application discovery services to launch our applications. So durability and availability in AWS, not the exact same thing. Durability is, am I going to lose any data if something goes down? Availability is, can my application stay up and running in the event that we lose something? We lose an instance, we lose an availability zone. What happens to my application if something like that occurs? Am I still available? Scalability and elasticity are not the same thing. Is my application going to scale well in the cloud based upon the amount of traffic that's hitting it? And is it elastic enough to allow it to do the horizontal type of scaling? So am I going to be able to go horizontally by adding more resources? In that case, that's going to allow the elasticity in. And can I scale back in when I don't need those resources? Like, what happens if I've, deployed 20 web servers because I had a spike in demand, but now I don't need them all? Am I going to be able to scale that back in and take that little bit of that capacity away and stop paying for that? Migrate your monolithic applications to microservices functions. So think about maybe going serverless here for the test as well. Look for serverless solutions before you're writing that code and deploying it onto EC2. So in the last 5 minutes, I'm going to cover quickly troubleshooting here, and that's going to finish us up for the day. You want to write code that can be monitored, and you want to try to perform root cause analysis on faults found in testing or in production itself. So AWS returns error codes from operations to a lot of our services, like 400 error codes. You go to create a bucket, for example, and that bucket name already exists. That's a 400 type error code. Whereas a 500 series error might be us pushing back on you on a particular service because you're sending in throughput at too high of a rate. DynamoDB is a good example of this. If you have a really, really hot key, for example, that's going to maybe send too much throughput to that one partition. We're going to have to push back on that with a 500 series error. We alwaways recommend collecting logs, system logs, HTTPD logs, things like Lambda, CloudWatch logs. Any logging activity, and taking that, if you're running instances, storing that off instances into something like a CloudWatch is really useful. Monitor. Remember, that can be the key to our elasticity we were talking about earlier. Monitor the health and performance of your instances. The availability of things like, are both of your RDS instances running across multiple regions. Network performance, utilization, as well as underuse resources. The monitoring can tell you whether or not you have too big of an EC2 instance deployed. Maybe you could get away with a smaller instance size. CloudWatch is our primary monitoring tool in AWS for utilization metrics and things like, just general system utilization as a whole. It happens to be an open API, so not only can we publish metrics into it, but you can publish metrics from your instances as well inside of CloudWatch. And one of the powerful things about CloudWatch is its alarm capability, which can have things like actions tied to it. So it can call a Lambda function, or it could generate an SNS alert, or it could launch an auto-scaling event, or any number of things you can tie to CloudWatch alarms. And alarms can have certain metrics that we're monitoring that maybe we don't want to trigger it on one-time spikes, but maybe we want to have a certain period of time expire. So maybe 3 periods of a minute apart, we want to actually trigger alert, whereas a one-time threshold breach won't necessarily trigger that alarm. Maybe it has to be over a period of, say, 3 different periods before that particular alarm gets invoked. And so you can set that up in CloudWatch so that you can set up when the alarms actually get triggered on. So a sample question from this section is, you have to configure CloudWatch alarm to trigger when CPU rises above 60%. It's currently at 80%. What is the status of the alarm? Well, it's currently set to trigger when it rises above 60%, and it's currently at 80%. Well, the state is alarm at that case. We're into an alarm state. Make sure you know the difference in CloudWatch and CloudTrail. CloudTrail is the audit log in AWS, and CloudTrail can help you answer questions like who shut down an EC2 instance, who deleted an S3 bucket, who changed the configuration of my RDS configuration, who changed permissions on something. That's the AWS audit log that gets stored in S3. That tells you who did what specific actions in AWS. AWS X-Ray is a tool to help developers analyze and debug applications, such as especially those that are built with microservices architecture. You can understand how your application and its underlying services are performing, so you can identify and troubleshoot the root cause of performance issues. So, your application's trying to upload a 6 gig file to S3 and receives a message that says your proposed upload exceeds the maximum allowable object size. What is the possible solution for this particular problem? So we're getting an error message that says the upload exceeds the maximum allowable object size. What could we do to fix that? Well, S3 object limits are not 5 gigs, they're 5 terabyte for a single image size, so that's not it. I like the multi-part upload option. Let's hold on to that. Upload to a different region, that's dumb. Let's see, use large object upload API. There's no such thing. Contact support to increase your object size limit. No, that won't work either. So B, use the multi-part upload API seems to be the way to go for that particular question. I realize we're at 7. I just have a couple more slides here, so a couple more, and then we'll finish this up. But I thought I'd show you these last few sample questions here. Let's see, which of the following is a true statement? The AWS error, internal error. We encountered an internal error. Please try again. This means that this is a It's an internal error. Please try again. Retries are almost always 500 series error. So it's not a customer error. It's not a 400 error. It's an S3 service. It's not an S3 service error. These are typically always 500 type errors that you get when you see that. So you're writing to a DynamoDB table, and you receive the following exception: provision throughput exceeded. However, according to the metrics, you're exceeding your provision throughput on the table itself. What could be the explanation for this? So we're getting provision throughput exceeded, but we're not exceeding our table's provision throughput. That's probably going to be, it's not that we haven't provisioned enough storage instances, because we're not exceeding our throughput. We don't have a range key exception, but we could have a partition key exception. The other two really don't make sense, so I like answer C in that particular case for that particular question. I did actually get this question when I took the exam too, by the way, just as a side note for you. I actually saw that particular error code show up. What happens by default when one of the resources in a CloudFormation stack cannot be created? If by default is the key word there, because that can be overridden, all right? So when CloudFormation encounters an error and something can't be created, then what happens is that the stack stops, and any resources that's created up to that point are deleted. So answer B, previously created resources are deleted, and the stack creation is terminated. And let's see here. I think I have just a couple more. Here we go. You received a 404 not found, no such bucket error code. What does this mean? So does that mean that S3 can't find a bucket name named no such bucket, or S3 can't locate the requested bucket? That's better. Not that the object's not available or S3 service is not available, it just couldn't find the bucket that you were going to look for, you were doing the retrieval on. So always check security groups and network access control lists when you're troubleshooting EC2 instances in a VPC. Instances launched into a VPC can't properly communicate with the internet unless you use a NAT, and need an internet gateway and a route to talk to the internet, so make sure you understand your routing rules inside of a VPC. And EBS volumes are loosely coupled on an EC2 instance. You can detach and reattach somewhere else except for the boot volume itself. So go through the exam guidelines. FAQs are very good things to read for all of the services that we talked about. They are rich sources for test writers to look through the FAQs and try to find ways to ask questions on that stuff. Number of AWS documentation. If you want to get some hands-on, try Quick Labs to spin up resources and do some personal projects there on maybe free tier accounts as well. One piece of advice that I got when I took my test was to go through and completely build a VPC from scratch, building out all the routing tables and the gateways and everything. I thought that was really good advice. I'll pass that along to you. But we are over time. I apologize. We're a little bit over time, but thank you all for attending.